Queuing system question, queuing theory system question. A belt snapping, let's start the question. A belt snapping for converts in a open cast mine at the rate of 2 per hour, 2 per an 8-hour shift. Okay, at the rate of 2 per 8 hour of shift. So it's creating 2 belts for 8 hours of shift. There are only one hot plate for vulcanizing, and it can vulcanize on an average 5 belt snaps per shift. How much it will? It has capacity of producing 5 belts, but how much? The shift is 8 hours, but only two belts per shift we are creating. Okay, we are manufacturing. What we have to calculate? What is the probability that when a belt snap and hot plate is readily available, and what is the average number of belt in the system? Average number of means we have to calculate the average formula. Average number of belts in the system. So first formula we have to take in, and then what is the waiting time of an arrival? Waiting time, WS. Okay, waiting time in the system for an arrival. Next, for an arrival, sorry, it's an for arrival, so we have to calculate average, means we have to calculate the queue, not for system one. Now the last one, what is the average waiting time plus vulcanizing time? Average waiting time, here we have to plus vulcanizing time means plus system time also. So we have to calculate this one with WS. Now first let's start solution. First, what we have given that what's given? Mean is equal to, mean means minimum 2 belts per unit. 2 belts, sorry, per shift. Here is a per shift, and mu is 5 belt, means capacity is 5 belts per shift. Now what we have to calculate first? We have to calculate what is the probability that when a belt snaps and the hot plate is readily available. Probability, so we have to check what is the probability, means we have to check in probability formulas. Okay, so probability if hot plate being available and probability of facility being empty. So what we have to calculate? Probability of hot plate being available okay. So what we have to take in a probability formula? So we have to take first is serviceability is not there, is not suitable. Then what we have to, probability that there are n units in the system, because it's a probability that when a belt is snapped and hot plate is ready, means how many system, then it will be readily available. How you will calculate this one? P of 0. Okay, P naught means, okay, probability P of 0 is equal to 1 minus P first probability is equal to 1 minus probability means always probability will be deduct from 1. So P means divided by mu. So 1 minus mean is how much? 2 divided by mu is 5. So take the LCM. 5 ones are 5 minus 2 is equal to 3 divided by 5. Okay, so how much? 3 divided by 5 is the probability of getting readily available of a plate. Second, what is the average number of belt in the system? Average number of belt means the first formula, number of units in the system. This is the first formula, average number of units in the system. Average number of belts in the system. Okay, here how we have to calculate? Okay, arrival in a system. So mean divided by mu minus mean. Mean is 2, mu is 5 minus mean is 2. So 2 divided by, so 2 divided by 3 means this is the answer. If you want to divide, otherwise keep like this. Okay, then third one, what is the waiting time of an arrival? What is the waiting time of an arrival? So calculate this one. For arrival, what is the waiting time? Waiting time means which formula? We have two formula for Q. What time? Average time in a unit in a Q, or average time a unit spent in the system. In a system it was not suitable because arrival means time of arrival. Arrival means he is in a queue, so that's why he has to be arrived. So which formula will we take? Sorry, this one. Mean divided by mu into mu minus mean. WQ is equal to mean divided by mu into mu minus mean. Mean how much? 2. Mu how much? 5. 5 minus 2. So 2, 5 into 3. 2 divided by 15. 2 divided by 15. Now the last one, fourth one. What is the average waiting time plus vulcanizing time? Average waiting time means waiting time in the system. Average time a unit spent in the system, 1 divided by mu minus mean. So take 1 divided by WS is equal to this for fourth one. 1 divided by how much? Mu is 5, mean is 2. 1 divided by 3 per shift. How much he has to wait vulcanizing time? Average waiting time plus vulcanizing time is 1 divided by 3 per shift. Chances of waiting. This is the how we can solve the queuing system theory problem by taking the correct formulas.